Hey, how's it going? So let's talk a little bit more specifically about the NateChrony ExtremeBallistic and whether or not it's going to be the right chronograph for you. Of course it is. So it's very, very hard to make a chronograph. They're all sort of different in different ways. Some chronographs work really well, others are crap. That's typically because it's not going to be the right chronograph for how you want to use it and what you want to do. There's always going to be little trade-offs, differences in how the chronographs are manufactured, which is going to affect how they perform in different situations. So I'll go through the design process of the NateChrony ExtremeBallistic to help you understand how it's going to be used, what are its little oddities, and whether or not, of course, it's going to be the right chronograph for you. So first of all, chronographs are a really, really difficult, hard thing to make. If you think of like a 177 pellet, 4.5 millimeters, it is tiny. That thing moving at 1,000 feet per second doesn't have a lot of impact on the environment around it, i.e. doesn't have a big radar return signature, doesn't block a lot of light or cast a very big shadow, which means chronographs are going to have to be extremely sensitive to be able to detect something so small that's moving so fast. Because they're so sensitive, that means they're going to be impacted significantly by external interference. There's a few different things that you can do around the external interference to how you want to sort of solve that challenge. Now, first of all, you can do nothing. That means they're going to be prone to errors. Things like shade, trees, birds moving on the opticals. You're going to get odd errant readings. Radars, other units being in use near you or other sources of interference are going to trigger them or give odd results. Then the other thing you can do is to decrease the sensitivity to sort of remove that environmental noise. Then you're going to get a lot of missed shots. They're going to be a little bit more harder to set up. You may need to put on additional external lighting for the optical ones to try and compete with the environmental interference. The other thing you can do is to completely remove the external interference by covering the entire unit up in a sealed unit. That's exactly what we do on the NateChrony. It's a small device that's completely enclosed, and we've got a lot of design elements to make sure that we remove any sources of interference from outside the unit, but that's because it's a small unit. For something like this, it would be a much larger, heavier, bulky enclosure. But still, you think something like a scan chronograph, very, very valid solution to basically build a box around it to remove any external interference. Valid solution, not the solution we went for. We want to make sure that we're sort of getting a solution that you sort of provide and we help you to provide as well. So the specific design approach, we've got the NateChrony muzzle-mounted chronograph for air-powered rifles, which has been going great guns. We've had that out for a couple of years. We've worked on that a lot with our customers, a lot of feedback, a lot of improvements to software. So hey, let's tackle the next challenge. Let's make a standalone one. A lot of odd-sized and shaped muzzles for air rifles. Let's make a standalone one we can then use for powder burners as well. So if we're going to make a unit that is going to be standalone, how about we make one that you can put at range, downrange, and do some cool things like ballistic calculations as well. So it's primarily designed to be put potentially downrange and just shoot through all powder burners, air-powered guns, etc. Probably not archery. First of all, accuracy. We will never compromise on accuracy. Every NateChrony chronograph is live shot calibrated from our master chronographs. Specifically for air rifles, they rapidly decelerate. They're dropping 30 to 40 feet per second at 10 meters. It's going to be calibrated at a distance of 300 millimeters from the muzzle. So using it indoors, using it in things like shops to do tuning work, to do testing to see whether or not they're at or below power limits. 300 millimeters, 30 centimeters, 1 foot is a pretty good distance to keep things nice and small. It's going to be a little bit short for powder burners, but they're going to not be decelerating too much. It may read a bit higher. If you need a specific calibration distance, let us know and we can get that done for you. Secondly, the feature set. So we've been working with our customers for years now in terms of the feature set, in terms of the software that it comes with, it's going to be second to none. You've got all the usual chronograph stuff, the speed, the power, all the graphing, statistical, standard deviations, averages, all of that. 4 different save slots. So we've tested it with 200 shots in the current string and 4 save slots of 200 as well. So that can save over 1,000 shots. It is super, super easy to download all the data off the unit as well. So you're going along, you can put descriptions on all the strings, quickly download, clear it, do the next session, really, really simply. It is just easy to work with. Something that you don't need an app that's all a bit clunky and odd. It's just a web page, no internet required, that sits on the device itself, and you can just download everything like you would browsing the web. Really clean, easy to use interface. There's no apps, there's no internet. So nothing to download, nothing to install from a questionable country on your phone, no permissions that you need to give my software to your contacts or your Bluetooth, none of that shenanigans. You connect to the device over Wi-Fi and you bring up the browser that exists on your mobile device and everything comes from the unit. No internet required, no apps, no privacy settings, no sharing of data, none of that rubbish, just like all our other NateChrony products. The environmental sensors as well. So it has inbuilt pressure and humidity sensors, which are going to be critical for doing things like that ballistic calculation as well, inbuilt into the device. So durability wise, like all NateChrony products, we want to sell one solid chronograph to you for life. Really dumb in terms of sales, but hey, everything is aluminium, powder coated aluminium. You can look at some of our durability tests. We've dragged the NateChronies down the road for a couple of 100 meters. They barely mark. It is a beautiful, beautiful textured architectural grade powder coating on aluminium. All the fasteners, all the screws are going to be stainless steel as well. Nothing's going to corrode, nothing's going to rust. So super durable. Things like humid conditions, places like even Sydney, Florida, where it gets quite muggy, you're not going to have the effect that it's going to have on other electronic devices as well. So we want to make something that we can put at distance, so we want to be able to do the ballistic coefficients. Let's look at some of the extreme cases. If you want to look at something like a 338 Lapua, over 100 meters, it's going to have a difference in speed of about 100 feet per second. That's an easy difference that we can measure, not a problem. So 1 MOA is going to be 1 inch at 100 yards, 100 meters, pretty much the same. We want to double that. So a detection area of 2 MOA at 100 yards. So we've got that 50 millimeters by 65. You can bring that back to 50 meters. That's still going to give you a speed difference of something like a 338 Lapua of about 50 feet a second, which is easy enough for us to detect very, very cleanly. So that will then get you a 4 MOA area at 50 yards. If you can't shoot 4 MOA at 50 yards, baby's first chronograph is probably going to be for you. So that's how we came to setting up the detection area, why it's the size it is. That's what we sort of worked back from in terms of requirements. So that's the detection area. Connectivity, as I said before, you don't want to be going down the range to try and get the results off it. We can't use Bluetooth. We use Wi-Fi, standard Wi-Fi to standard antenna. If it ever breaks, just go and get one locally. You'll easily get readings up at least 100 meters. You can put a bigger antenna. You'll get much further than 100 meters of range to be able to read the results of this from your tablet, from your phone. When you're at range, we use the LED indicator. This is from our smart targets. So you just plug that into the side instead of the screen, remove the screen, and that's going to tell you, hey, I detected the shot or I didn't detect the shot, so you know what's happening at distance or not. So the physical design, and this is going to be the thing that is quite different and unique about our particular product. And you'll see why this is actually designed for shooters. The fact that you're using a chronograph, you are not 100% certain about the projectile's velocity. That means that the elevation of that projectile is going to be somewhat unknown. You're also going to be using a chronograph, I dare say, at very, very different distances to what your scope, your sights are going to be calibrated for. So the dumbest thing you could ever do is to put a screen or buttons above or below the shooting window, because you're going to shoot the thing, you're going to destroy the screen or the buttons and then throw it in the bin. So we just did the simple thing of putting the screen on the side of the unit. So you can shoot above or below the ballistic plate. You're never going to hit the screen. When you're putting this at distance, you're not going to be able to see the screen. Simply undo that screen take it off, put on the indicator, you're never going to shoot that screen. So really simple when you think about it, but just designed knowing how it's going to actually be used in real life. So we've got the really, really high brightness OLED screen, the LED indicator. And again, you can see it's going to be flat packed, super compact, very lightweight. You're just going to screw it together with 8 different screws, nice and simple. Really, really lightweight as well. So we want to think about how do we keep the cost down for our customers. If we can reduce the size of the unit, it's going to require less materials to make. So less materials, less cost, we can keep the cost down. Because it's less material, it's going to be a lot lighter as well. So that's going to keep things like shipping costs. So we're going to have very, very small compact packages that are going to be on the retailer shelves. They love that. And when you're not using it on your shelf as well, it's just going to be in a nice little box, super lightweight, super small and convenient to store when it's not in use. Because maybe you're not chronographing every week. Maybe you're bringing out every quarter or so. You want something that you can sort of pack down and be a little bit compact as well. So it's all aluminium. The internals are plastic, 3D printed, yes. Really, really lightweight, easy to manage from that. Now, the one downside, as we sort of said before at the start, is that you need to be responsible for controlling the environment. What that means indoors, not a problem at all. It's not affected by fluorescent lights, LED lights. Outdoors, it needs to be in the shade. Now, we've just tested it. It's currently 35 degrees in the heat here in Sydney, Australia. You just need to make sure that this is put in the shade. If it's in the full sun, specifically if you get sun on the emitters down the bottom, it's going to saturate the sensors. You won't detect a shot. So that's going to be the challenge there. Make sure that you've got some shade covering around it, and then you're going to be completely fine. Use the outdoor screens for the sensors versus the indoors. That's going to help you adjust it. Now, when you do have it set up in the environment, you put it out there, you power it up. You then use the little driver to calibrate the sensors. You want to make sure that you're sort of setting them so that you're on the edge of the detection range. That's going to help you get the most accurate and reliable detection. This is really around things like air rifles. A 177 Diabolo-shaped skirted pellet is really, really challenging to work with because it's so small and because of the waste. It sort of blocks the light, lets the light through, and then blocks it again. Really challenging problem. As soon as you jump up to something like a 22 caliber, easy as pie, not a problem. So the sensor adjustment is really there to get ultra reliability for our 177 air rifle pelleted friends. Things like slugs, 22 caliber Diabolo pellets, easy as. If you're using things like 30 cal or bigger, easy in terms of setting up the sensitivity. You can really wind the sensitivity down and you're going to detect those larger projectiles, especially something like a slug or a traditional projectile shape as well. So it's designed to be bulletproof as well. Little asterisk there. What does bulletproof mean? It comes with a standard 1.6 millimeter aluminium front plate. That's going to be able to handle 15 to 17 foot-pounds at point blank. So you're going to shoot it, it's going to deform. It has flexible rubber mounting points so that if it does deform, it's not going to affect the structure of the chronograph and break or cause issues to that. If you're going to shoot something bigger than that, you want to shoot 50 caliber, 338, whatever it is, you just need to replace that front plate with something of the appropriate size. Now, you're not going to buy it from us. We will provide the designs for that in the chronograph itself. You can just download the design, send it to a target manufacturer or your local steel place to get it laser cut out of the appropriate size steel or whatever you need to put on the front of that. So you provide the bulletproofness, screw it on the front. You're never going to hit it. You're never going to damage the chronograph because you've made it bulletproof. Really, really simple. And again, we've thought about how this is going to be used. Everyone loves to shoot the chronographs. Let's make it bulletproof, right? Pretty easy. Now, in terms of mounting as well, tripod's pretty standard and just screwing it down to a platform. So I've got a tripod, standard 1/4x20 thread there, and also just these side things that you can remove to just screw it down into a bit of timber. The tripod mount is sacrificial. So if you absolutely belt that on the tripod, there is an internal plastic mount that is designed to be sacrificial and break. That is so that you don't damage the chronograph and you don't damage your tripod. Much like the NateChronies, they're muzzle mounted. We have a sacrificially designed mounting point so that you don't damage the end of the rifle threads or the expensive chronograph. You get 2 mounting points, and that design again will be free. You can download, get it 3D printed. It's just 4 little holes and a center hole, simple. And if you do break it, you can actually just put a bolt straight through it, not a problem. You can see that the top of that extends above the chronograph so that you could put a battery pack and have it protected behind the ballistic plate if you don't want to mount the battery far, far away. So that's the design of the NateChrony ExtremeBallistic. Again, a unit that's designed to be put down range. We've got a 2 MOA at 100 yards, 4 MOA at 50 yards, external shot indication, removable screen, durability, powder-coated aluminium, stainless. You can adjust the sensitivity, get it in the environment, and make sure it's ultra-reliable detection and results. So that's the NateChrony ExtremeBallistic. This is why we made what we made and how we made it. If that's going to be the chronograph for you, then go ahead and purchase one. They will be shipping the week after Christmas this year. Enjoy your testing.